Hello students, I am your maths teacher. In today's class, we are going to revise for our September monthly test and I have done the sums based on the concept students. Understand properly, do your test well. Now we'll start with the sums. Just 10, 100,000 like that. According to the question, we are going to do the sum students. First, what is the question asked here is correct to the nearest 10. What I am going to do is I am going to take like this ones, tens. So what is the, I have underlined the number here. What is the number here I am having is 75. In 10th place, what is the number? 7. So the underlined number, I am going to keep this 7 as it is. In place of 5, I am going to put it as 0 in my number line. So starting from 70 to 80, I am going to take the range. The middle number is going to be 75. Suppose if you are not able to find the middle number for that particular range means add the two numbers, divide by 2, that is 70 plus 80 divided by 2 means you will get the value as 75. So what is the purpose of writing like this? What is the number given here? 75. In my number line where I am having 75 in the middle. So while I am getting the number in the middle means it will be going towards 80. Suppose if you are going to get a number 74 like that means it will go towards 70, nearest 10. So the nearest 10 here is the remaining numbers 6, 8, 4, 4, 3, 6. Up to that I will write the number as it is. Only the underlined number 75. Instead of 75, the nearest 10 here is 80, 80. So that is the concept of doing the sum students. Similarly for 100, if you are going to take for 100, you are going to see the 100th place. What is the number? 6. Remaining 2 put it as 0. So it will be 600. 600 to 700, I am going to take the range. Middle 675, 650 is the middle value. Between 650 to 700, you will be having the numbers 675. So the nearest 100 here is 700. So the nearest 100 I have underlined here is 700. Coming to 1000. Same way 3675. Between 3000 to 4000 you will be having the number. 3500 is the middle number. Between these two ranges you will be having 3675. Just take this particular range of values. Instead of that, the nearest 1000 is 6844 will be as it is. Instead of 3675, the nearest 1000 here is 4000. Question number 4. Estimate each sum to the nearest 10. They will be asking you to find the addition. Before doing the addition, first we are going to estimate the number. That is, we are going to find the nearest 10. For that particular number value, we are going to add the values. So what I am going to do here, students, 43 plus 28. 43, I am going to take the range. Between 40 to 50, I will be having the number 43. That is 40, 45, 50. The number 43 will be in between 40 and 45. So, the nearest 10 here is 40 and similarly for 28. The nearest 10 is 30. Add the numbers, you will get the answer as 70. Similarly, coming for 13 plus 58. 13 will be in between 10 to 20. The middle number is 15. Between 10 to 15, you will be having the number 13. The nearest 10 for 13 is 10 and nearest 58. Nearest 10 for 58 is 60. Add the two numbers 70. Similarly, for the remaining all the things you are going to do in this way, students, but particularly if you take this particular number, 3-digit number, 173 plus 387. You are going to find the nearest 10. What I am going to do is, I am going to underline the number 73. Ones tens. You are going to check only for 73 here. If I take this particular value in the number line, between 70 and 80, you will be having the number 75. That is 70, 75, 80. Between 70 and 75, you will be having the number 73. So, the nearest 10 here is 70. But I am not going to write it as 70. Before what is the number I am having here? 1. So, The nearest 10, the round of value is going to be 170. Similarly for this one, 3, I am going to keep it as it is. 87, the nearest 10 is 90. 390. Add the number, you will get the answer as 560. Similarly, estimate each of the following product. In this place they will not tell you nearest 10, 100,000 like that, but we will be estimating the sum according to the number of digits. So 27 into 73. 27 estimated product means first I am going to convert into tens, 100, nearest 10, 100 or 1000. So in this place I am going to find the nearest 10. 27 I am going to write it as 30. Nearest 10 is 30. 73, nearest 10 is 70. 30 into 70, you will get the value as 22,100. So this is a way of doing the sum, students. Similarly, 43 into 58, the nearest 10th is 40 into 60, 58, 60. Multiply, you will get the answers 2400. Suppose if I am going to take the fourth sum, 523 into 77. Here we are having 3 digits, here we are having 2 digits. In that case, I will be taking the 3 digits as it is. I will be taking the 3 digits as it is. 523, nearest 100th place is 500. Here the nearest 10th place is 80. Multiply the number, you will get the answer as 40,000. So this is a way of doing the sum, students. And coming to the next one is, we are going to find the quotient. Question number 11. Find the estimated quotient of each of the following. Quotient means we are going to find using division method. 87 divided by 27. Nearest 10th for 87 is 90. Nearest 27 for 87 is 30. Divide the value, students, you will get the answer as 3. So the nearest estimated quotient is 3. Coming to the next question, the nearest for 98, that is the nearest 10th is 100, and nearest for 32, 10th place is 30. 100 divided by 30, you will get the value as 10 by 3. So when I am dividing this particular number, I will be getting in the form of decimal point. I will not move to the decimal point. So 3 3s are 9, 10 minus 9, 1. I am not going to move further. Since if I want to keep the decimal point, I will not go to that particular place. I will keep this 3. So 10 divided by 3 is approximately equal to, the meaning for this symbol is approximately equal to 3. Your answer is not exactly 3, which is approximately equal to 3. So the quotient here is, estimated quotient is 3. Similarly, for the next question, for 74, the nearest 10 is 70, and for 34, the nearest 10 is 30. Divide the value, students. 70 divided by 30, 7 by 3. If you divide, you will get like this remainder. After the remainder, I am not going to move for the decimal point. This particular place is called as quotient, which is approximately equal to 2. So in this question, 815 divided by 33. Here, a first sum is 35 a factor of 455. Whenever they are going to ask you whether the particular number is a factor of the given number, means you are going, now what is the question given here, students? 35. They are asking you to check whether 35 is a factor of 455, means I am going to take my rough book now. Just 455 divide by 35 table, directly by 35 table. So while I am dividing, I should get the remainder 0. If I am going to get the remainder 0, so what is the meaning? 35 into 13 is equal to 455. That is the concept. So I will be dividing. Whenever they are asking you to check a particular number is a factor or not, means I will be dividing the number. By dividing, if I am going to get the answer as 0, means then this particular number is known as factor of 455. So the first question, 35 is a factor of 455. Same way, for 13 also you are going to check. If I am going to, is 13 a factor of 816, means I will be 816, I will be dividing by 13 table, students. While I am dividing, I am not going to get the remainder 0. It is going to, till it will be crossing the decimal point. So in that case, the particular number is not a factor. I will not get the remainder 0. So that is a concept. But if you see the third sum, they are asking you to check in 2 tables, that is using 5 table you are going to divide this number, and using 3 table also you are going to divide this number. While I am dividing by 5 table, that is 1647, while I am dividing by 5 table, I am getting the remainder 0. When I am getting the remainder as 0 is while I am putting the decimal point, after decimal point only I am getting the remainder 0. So that will not be accepted. After decimal point will not be accepted in the case of factor. So 5 is not a factor of 1647, and 3 while I am dividing I will be getting the answer as 0. So 3 is a factor of 1647. The next 3, 7 are factors of 154. Same way I have done the rough work, students. You are going to check, you are going to see the tables. While you are getting the remainder 0, automatically it is a factor. If you are not going to get the remainder 0, it is not a factor. You are going to just work out and see the 4th and 5th sum. Coming to the second question, students. Second question is not a big concept, very easy, only based on tables. I am just going to read only the questions. Write the first 8 multiples of 7 means you are going to take the 7 table. I have done in the rough work. You are going to take the 7 table, students. 7 ones are 7. Starting from 1 to 8, you are going to multiply the value with the table 7. So 7 ones are 7 to 7 eights are 56. I will be calculating. And whatever answer I am going to get here, those answers I am going to write here. That is, the first 8 multiples of 7 is 7, 14, 21, 28, 35, 42, 49 and 56. And those are the answers we are getting in 7 table. Coming to the second question, write the first 10 multiples of 5 means 5 table. 5 ones are 5 to 5 tens are 50. Those values you are going to write. And similarly, third question, write the first 6 multiple of 11 means 11 ones are 11 to 11 six are 66. And the answers we are going to write it here. Before starting with sum number 3 and 4, we are going to see the concept of prime, composite and co-prime. So what is the meaning of prime? First we will see the example. If I am going to take a number 2 means I must get the answer 2 when I am multiplying. So 2 ones are 2, 1 twos are 2. Similarly, if you are going to take the number 3 means, if I multiply I should get the answer as 3 means 3 ones are 3. 1 threes are 3, except this I will not get the answer as 3. So if I want to get the answer as 3, 2, 3, 5 means while I am multiplying, only this is the possible concept. So if you see a 1 and the same number, 1 and itself and exactly 2 divisors, this is called as 2 divisors. So regarding prime number, a number which has exactly 2 divisors, that is 1 and itself the same number, is called a prime number, and that is the example I have given here, students. Composite number also the same concept will be repeated, but you will be having more than 2 divisors, and you have to be clear in this place. All the numbers are multiplied by 1 and itself, but the numbers which are multiplied by 1 and itself is known as prime number. And the numbers which are multiplied more than 1 and itself is called as composite number. So if I am going to take the number 4 means I should get the answer as 4 while I am multiplying means 4 ones are 4, 1 fours are 4, 2 twos are 4. Similarly 6, 6 ones are 6, 1 six are 6, 2 threes are 6, 3 twos are 6, and similarly 8. If you see all these concepts, in this place also the number is divided by 1 and itself, and other than that I am getting another divisor. So it is crossing more than 2 divisors. A number which has more than 2 divisors is called composite number. So that is the difference between prime and composite. Coming to co-prime. So what is the speciality of co-prime? Is there any co-prime means I am not going to take only the prime number, I will take any number, but the concept here is I will be comparing 2 natural numbers here, students. Be careful, I will be comparing 2 natural numbers are called co-prime numbers if they do not, understand the concept, if they do not have a common factor other than 1. They will not have any common factor except 1. For example, I am going to take 2 natural numbers, 2 numbers, 3 and 8. And why they are telling it as natural numbers means you have to take only positive values. That is the meaning of natural numbers, and starting from 1. That is the concept they are telling here. I am going to take the number 3 and 8. 3 can be written as 3 into 1, and 8 I have to split it in the form of factors. 4 2s are also 8, but it should be a prime values, that is 2 into 2 into 1. Maximum you have to break that number. 8, 2 into 2 into 2 into 1, maximum possible factors of 8 is this one. Now if you compare the factors, nothing is common except 1, no other number is common. So this particular combination 3 and 8 are called co-prime numbers. I'll be comparing two numbers. 3 and 8 are called co-prime. Why means only one is common to both and no other number is common to both the values. So using the concept of prime, composite and co-prime numbers, we are going to see the sum number 3, students. That is, write all the prime numbers between 1 and 50. You are going to write the numbers in an order from 1 to 50, that is 1, 2, 3, 4 till 50. I am going to write all the numbers here, students. And in that I am going to check all the values, and whatever values I have circled here is called as a prime number because it is the number which is divisible by 1 and itself. So the prime numbers between 1 and 50 are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and 47 are those numbers which are known as the prime numbers between 1 and 50. And the speciality of 1 is, while I am talking about prime and composite, the number 1 is known as both prime and composite numbers. So be careful in that place. The next one is, they are asking you to find the co-prime pairs, that is, make a pair of co-prime numbers from 15, 21, 28, 16 and 11. I am going to take 15, 21, 28, 16 and 11. I am going to find the factors. What I am doing here is, I am splitting the numbers as much as possible. You are going to split the numbers in the form of factors. Even this 21 can be written as 7, 28. 7 4s are 28 is also correct, but that 4 is also splitted as 2 into 2. And if you check here, all the numbers are co-prime. I'll be splitting in the form of prime numbers. So you will not have any composite number. You have to be careful in this place. So how to form a co-prime number pair? Just take the number 15 first. 15 I am going to compare with 21. If you see, the number 3 is repeated, so I cannot pair. Then 15 I am going to compare with 28. Except 1, nothing is common. So 15 and 28, they will get matched. 15 and 16, check and see, nothing is common except 1. So 15 and 16. Similarly 15 and 11. Like that you will be checking. Once 15 is over, I will just remove this 15. Then I'll just close this one. And the next one is, I will be taking 21. 21 and 28, while I am comparing, 7 is common, so I will not match it. 21 and 16, while I am comparing, nothing is common other than 1. So 21 and 16 I will be writing here. 21 and 11, nothing is common. So 21 and 11 is a co-prime values. Once 21 is over, close this one, come to 28. 28 and 16, it is not a co-prime number since 2 is common to both. 28 and 11, co-prime, because other than 1, nothing is common. Coming to 16, 16 and 11, both are co-prime. So that is the concept of co-prime numbers. That is, we will be comparing the two numbers. Except 1, no other value should be common to both. Next, we are going to move on to rules for test of divisibility. Divisible by 7. They are giving you a rule here. A number is divisible by 7 if the difference between twice the ones digit and the number found by the other digits is divisible by 7. Let me give the sums. You will understand why I am doing the sums. 2, 5, 3, 4, 7. I am just underlining the ones digit for your understanding here, students. What I am going to do is 2, 5, 3, 4. Keep it as it is. They are asking you to find the difference between twice the ones digit and the remaining digits. 2, 5, 3, 4. Keep it as it is. Put a minus sign. Ones digit, what is the value? 7 into 2. That is the concept they are telling you. You are going to 7 2s are 14. Subtract the value. You will get this number 2520. This number you are going to divide by 7 table and you are going to find it out whether it is exactly divisible by 7 table or not. That is, the remainder must be 0. Once if this number 2520 is divisible by 7 means automatically I can say 25347 is divisible by 7. And similarly you are going to try the remaining sums. If the number is going to be not divisible, similarly I am doing this value, students. 5392 is not divisible by 7 means then the given number is not divisible by 7. They are asking you to apply the rule. That is why we are finding out using the rule concept. Question: test of divisibility by 8 table. So what is the condition for 8 table? A number is divisible by 8 if the number formed by the last 3 digits is divisible by 8. So what is the idea they are telling here is, they will be giving you a number like this 3864. I am going to take the last 3 digit. I am underlining here, students. 864. I am going to take this 864 and I am going to check whether it is divided by 8 table or not. Once if you are going to get the remainder as 0, 864 is divisible by 8 means that automatically I can say that 3864 is divisible by 8, and that is the procedure we are going to do here. So if I am going to take the second sum 8116 116 I am going to check whether it is divisible by 8 table. If it is not divisible means then I can automatically say 8116 is not divisible by 8, and that is the procedure we are going to do for the remaining sum based on 8 table. We are going to underline the last 3 digits and for that particular digit we are going to find the division for using 8 table. Once if you are going to get the remainder 0, it is divisible. If you are not going to get the remainder 0, it is not divisible. So that is the concept of 8 table, students. Question number 8, test of divisibility by 9 table. So what is the test of divisibility by 3 table means? We are going to find the sum of digits. The same thing, exactly the same thing. A number is divisible by 9 if the sum of its digit is divisible by 9. The first question they are given here is 4266. 4266. I am going to find the sum of digits, that is 4 plus 2 plus 6 plus 6. I am going to add the value, students. I am getting the answer as 18. This particular number 18 is divisible by 9. So automatically I can say 4266 is divisible by 9 table. Coming to the second question, if you see the second question 65,319, I am going to sum the digits, that is 6 plus 5 plus 3 plus 1 plus 9 equal to 24. But this number 24 is not divisible by 9 table. So automatically I can say 65319 is not divisible by 9 table. So the procedure for 3 table and 9 table is both the same, and we are going to check according to the 3 table and multiple of 3 table and multiple of 9 table. I am just telling that both the concept are same for rule, both the rule are same for 3 table and 9 table. Same way you are going to do the remaining sums based on the test of divisibility by 9 table. Question number 9, test of divisibility by 10 table. So what is the test of divisibility by 10 table? A number is divisible by 10 if its ones digit is 0. Definitely the ones digit must be 0. Only if it is 0, I can say that the number is divisible by 10 table. So I am just taking the questions here, students. I am just underlining the ones digit. I have just written like this. Ones digit, if you are having 0 means yes, the meaning of yes is it is divisible by 10. 6 means it is not divisible by, no means it is not divisible by 10. So when I am checking, only the first and third question is satisfying the rule given for 10 table, and the remaining it's not divisible by 10 table. Coming to the next question, 10th one, test of divisibility by 11 table. So that is the important rule, and you have to understand the rule properly here, students. That is, a number is divisible by 11 if the difference of the sum of the digits in the odd place and the sum of the digits in the even place is either 0 or divisible by 11 table. That is the concept they are telling you. They are asking you to find the difference. So, three things we are having here: sum of odd digit, sum of even digit. We are going to find the difference. After finding the difference, if you are going to get the answer 0 or the multiple of 11 means I can say the given number is divisible by 11. So, in this place I am going to take this question first. 3773. They will be mostly using from right hand side, they will be calculating the value, but I am going to tell you in another way. What I am going to do is, I am going to tick the values like this, students. 3, just leave one number and tick another number. The remaining, just I am jumping one number and another number. 3, put a tick. Next number put a circle, next number put a tick. That is odd, even, odd, even. That is a concept I am telling here. Sum of digits in the odd place. Odd place means I am starting from the first value. You can right to left, they will be moving, but I am going to move from left to right. 3 and 7. Since it is addition, no problem. And whatever way you are going to add, you will get the answer same. I am just putting a tick. Those ticked values are in the place of odd places. 3 and 7 I am going to add. I will get the answer as 10. The circled value, that is the sum of digit in the even place. The position just see here, even place. 1, 2, 3, 4. Or if you come from left to right, I am telling. Right to left means 1, 2, 3, 4. Even place, odd place. That is the concept. 7 plus 3, 10. I am going to find the difference. If you subtract these two values, you will get the answer as 0. So, I am getting the answer as 0. Therefore, 3773 is divisible by 11 table. So, second question, 2230908. You are going to check whether it is divisible by 11 table or not. What I am going to do is, I am going to put a tick like this alternatively. The remaining numbers will put a circle here, students. The ticked numbers are in the odd place and the circled numbers are in the even place. So, sum of the digit in odd place, that is the ticked values are in the odd place. So, just add the number 2, 3, 9, 8. I am adding, I am getting the value as 22. Sum of the digits in even places, the value which I have circled, add, you will get the value as 2. Find the difference, you are getting the value as 20. So, 20 is not divisible by 11. So, automatically the given number is not divisible by 11. Similarly, you are going to try the next sum. That is, I am just putting a tick alternatively. The remaining numbers, for your understanding, I am just going to put a circle. The number as a product of prime numbers. They will be giving you a number like this, students, that is 36. We are going to find the prime factors. How I am going to do is, I am going to do like this factors method. 36 right here. Now only we saw the rule for from 2 to 11 table. You can use that method, or generally you can divide by 2 table and see in that way. Side values are going to be only prime values. So, what I am going to do here is 36. The number is ending with 6. Divide and see. You will be getting the value as 18 in this place, quotient. Write this 18 here. Again 2 9s are 18. 9, 3 3s are 9. 3 1s are 3. So, when I am getting the value as 1, in that place I will be stopping my factorization. So, what is the number I am getting here? 2 2 3 3. 36 I am breaking as, I am expressing as a product of prime numbers, that is 2 into 2 into 3 into 3. 2 2s are 4, 4 3s are 12, 12 3s are 36. So, that is the way 36 I am splitting the number I am showing you. That is prime factorization, prime numbers, splitting in the form of prime numbers. Same way you are going to try for 42, and similarly you are going to try for 72 table. But all the side values should be only prime number, students. Don't take any other composite number is not allowed here, only prime numbers. If I am going to take 8th question, 1 2 3 2. Take the number, you are going to find the factorization 1 2 3 2, divide by 2 table, like that. Divide, the quotient value will be writing as 6 1 6. Again it is ending with 6. 2 table, divide 308. Again divide by 2 table, Like this it goes on, students. 7 table means 11. 11 is a prime number. Take it out directly. 11 ones are 11. So while I'm ending with 11 1, I'll be stopping my factorization. The side values, that is 1232, can be expressed as a prime numbers, that is 2 into 2 into 2 into 2 into 7 into 11. Again, if you multiply, you will get the same number exactly. And that is the way we are doing the calculation in all these places, students. So here 5, 3, 11, 11, 13 all are prime numbers. So try the calculation, do by yourself and see, divide the values,